The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, and welcome to another ATRA presentation. We are being sponsored today by Seal Aftermarket Products. And Seal Aftermarket Products has also provided us with a short product video that I'd like to show to you next.
Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancement, patented components, and all the little extras you won't find elsewhere. With kits for over 250 different domestic and import applications, distributed globally. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, if you have any questions or comments about the webinar itself, please send the emails to webinars@atra.com. Obviously, if you have any questions during the webinar, please feel free to go ahead and text them to me, and I will answer those at the best that I can. I've mentioned this before. This is obviously the last week before the expo next week. Go to your Play Store on your smartphone and type in ATRA Expo, and we have an app that you can download for free. Once the app's installed, you can see that one of the features here is the map of the trade show floor plan. This way here you can walk around the trade show and use your smartphone as a guide. The really neat part of this app is you can click on management or technical seminars. It'll give you a list of the speakers that are speaking. If you click on the speaker himself, it'll give you a small bio of the speaker and also include the information that he's going to be presenting. Last week we mentioned that there was a contest for a free limo round-trip ride from the airport that was announced yesterday on the 20th. The winner is Stephen Alvey of Custom Transmissions in Spokane Valley, Washington. Congratulations, Steve. Enjoy your limo ride. If you ever see any material that's not shown in your handout on any of our webinars, just double-click on that little camera icon that you see on your screen up in the upper right corner. That will leave an actual picture of that screenshot right on your desktop. For some of you guys that did not receive the Adobe handout, the handout material, when you receive this email invitation, you can see here where it says click, and it's got the word here in red. If you click on that word, you'll get you'll be able to download the presentation. Another thing I want to remind you of, if you want to join the mailing list so that you'll automatically be emailed every time a new webinar comes up, go ahead and just click on that mailing list on the bottom left, and you'll be added to that. If you know anyone else who might like to attend some of the webinars, again, you know that they're free for everyone because of the sponsorship. Go ahead and just click on the one on the right, put his email address in there, and he'll be added to the list. And of course, go to your time zone that you will be wanting to attend, and just click there and register for that time zone. Alrighty, today we're going to be talking about Toyota 4x4s. There's several different types, different systems, and we're going to try to go through those as quickly as possible for the amount of time I have allowed for the webinar. There are two basic types of four-wheel drive system used in Toyotas. There's a part-time four-wheel drive. Obviously this one is designed to operate in four-wheel mode in off-road or slippery conditions only. Therefore, that's why it's named part-time. There's a full-time four-wheel drive system. There's three versions of that. The four-wheel drive vehicles can be operated in all driving surfaces, so it can be dry pavement or off-road. There's a full-time always-on four-wheel drive system. There's a full-time multi-mode system, which the driver can switch it on or off. And then there's the full-time on-demand system. And we're going to cover all of these as we go through the webinar. Before we get started on that, I want to mention that there's two different design transfer cases that you'll find on Toyota models. At first, it was a gear-driven design that was used in pickups and 4Runners up until about 1995, although the Land Cruiser did use an exclusive gear type on some later models. Obviously, the power flows from the input shaft through the gears and transfers the torque to both the front and rear drive shaft. The center differential on these gear-driven design transfer cases can be driven in a high or low speed using an idler gear. Now, the idler gears are coupled to the center differential by a number 1 high-low clutch sleeve. Now, the front drive clutch sleeve locks the center differential to the front output shaft. There's also an oil pump that is driven by the idler gear that lubricates the transfer case. Changing from high to low speed is done through a floor-mounted shifter only when the vehicle is at a stop. During the shift into the high speed, the high-low sleeve and the idler assembly moves to the right at the same time as the number 1 high-low clutch sleeve on the center differential. When selecting lower speeds, the low-speed idler gear is engaged with the high-speed idler, and the high-speed output gear is disengaged from the center diff. The high gear ratio between the smaller, lower speed idler gear and the larger low speed output gear provides a low gear ratio. When you want to select high speeds, the high speed idler gear disengages along with the low speed idler gear, and the high speed output gear engages the center diff at the case. This places the transfer case in a 1-to-1 ratio. Because now at this point, the input drive, the high-speed output gear, they have the same amount of teeth, so we're going to have a 1-to-1 ratio here. Now, as the center differential case is driven, the pinion shaft transfers the torque through the pinion gears to the side gears driving both output shafts. This can be accomplished by either an electronic shift actuator or motor. Now, the chain-driven design transfer case is what we're all familiar with. These type of transfer cases use a planetary gear set instead of a countershaft to provide a low-range reduction. This design uses what they refer to as a silent chain instead of an idler gear. The transfer torque to control the transfer torque to the front output shaft. Now, a synchronizer assembly is used to change from 4 low to 4 high without stopping the vehicle, so we can obviously shift this one on the fly. The front drive clutch sleeve connects the output shaft to the chain in 4-wheel drive. This is how they drive the front output shaft. This design also uses an oil pump for lubrication. Talking about oil pumps, the type of pump that most found in these vehicles would be called a trochoid pump assembly. It's internal to the transfer case. Now, the oil pressure from this pump is actually regulated by a relief valve. Now, the pump is driven by an outer gear on the planetary spline piece that's actually attached to the output shaft. Now, the oil is circulated onto the gears and any friction areas through paths and different channels. Let's talk a little bit about the center differential assembly. The all-wheel drive transfer cases use a differential between the front and rear drive axles or shafts. This is due to the front wheels traveling at a different distance through turns than the rear wheels. Obviously, when we're making that turn, the front wheels are going to make a wider turn than the rear wheels. This is why it's important that all 4 wheels be the same brand tire and the same size. Although different brand tires give you the same size measurements, no 2 brands will actually be the same. So you have to have the same brand on all 4 tires. Same thing goes for the pressure. You have to have the same amount of pressure in each tire, and also the wear pattern has to be the same. I've seen as much as of a 1/4 inch difference in wear on the tires cause all kind of bind-ups and wheel hops during turns. The center diff assembly that we were talking about, this is in the free mode. This is when we're going straight down the road. The when you're going straight down the road, it distributes the power between the front and rear shafts. Now, in a straight line, there's almost no speed difference between the front and rear wheels. Obviously, there shouldn't be. That's why it's important about the size, the pressure, and the brand. The transfer clutch hub, the front drive sprocket, and the rear output shaft are all rotating at the same speed with the center differential, as you can see here on the right. Now, driving force from the transfer clutch hub is transmitted to the front and rear wheels through the planetary ring gear, to the pinion carrier, and to the sun gear. When a difference in speed is generated between the front and rear wheels, obviously during a turn, the pinion gears rotate and absorb that speed difference. Now, the carrier rotates faster, but in the same direction as the ring gear. Now, this causes the outer pinions to rotate in the opposite direction while rotating around the ring gear in the same direction. The inner pinion gears rotate in the same direction as the ring gear. Now, the rear output shaft rotation now becomes slower than the drive sprocket by the amount of rotation of the inner and outer pinion gears. Now, this is the center differential assembly in the lock mode. The center diff, like the front and rear differentials on any differential, is open. So that means that it distributes the torque to the shaft with the least traction. In the four-wheel drive mode, if one wheel loses traction, all the torque is sent to the shaft with least traction, causing the vehicle to become stuck. Now, by locking the center diff, the torque is distributed to both drive axles equally. This is the same as a part-time or conventional transfer case. The opposite drive shaft will move the vehicle. Now, the locking sleeve in the differential moves to the right, allowing the inner teeth of the lock sleeve to mesh with the rear output shaft itself. This is what we're talking about right here. Here's the lock sleeve. This blue section would be the output shaft. This is all locked into one piece, and that's how that works. At this point, the center differential stops operating and the transfer case is basically locked. Torsion limited slip differential. This is called the LSD. As we mentioned before, unequal tire size will cause different axle speeds. Now, this can increase the wear on the drive axle as well as the center support or the center differential components. Now, a torsion limited slip center differential is equipped in full-time and multi-mode electronic shift transfer cases found on most 2003 and later Toyotas. Now, the LSD is not designed to be disassembled. It's only replaced as a complete assembly. Now, the LSD also has a planetary gear set assembly with a sun gear and ring gear. This includes 4 clutch plates to distribute the torque to the wheels with traction. The clutches apply instantly and compensate for any differences in the front and rear wheel speeds. Now, when the front drive shaft is spinning faster than the rear drive shaft, obviously on a turn, the sun gear and ring gear will create a thrust that will transfer the torque to the axle with the traction. As you can see here, the sun gear is controlling the front output torque going through the clutch plate number 4, and the ring gear controls the rear output torque from clutch plate number 1. Here's a cutaway view of that. It kind of explains it a little easier. As you can see here in green, this is our ring gear, and there's our clutch plate number 1, so we're actually applying force to that. The sun gear in orange, as you see here, applies force to the clutch plate number 4. Let's talk a little bit about the actual planetary set assembly. The input shaft is splined to the sun gear. Obviously, the 4 pinions are part of the carrier. A spline piece is attached to the rear of the carrier and internal gear teeth of the spline piece. These can be engaged with the external teeth for changing from high to low using the high-low clutch sleeve. Now, the ring gear is attached to the transfer case, and the internal teeth are meshed with the pinion gears. The high-low clutch sleeve can be engaged with the splines on the rear portion of the input shaft. Now, the high-low clutch sleeve engages the planetary assembly to provide gear reduction for lower speed. Connecting the input shaft to the output shaft will give us a higher speed maneuver. Now in the two-wheel high and four-wheel high position, the engine power is transmitted from the input shaft to the rear output shaft locked by the clutch sleeve. And you can see that right here. We have the two shafts locked together using the actual high-low clutch sleeve. Now as the high-low clutch sleeve slides over the splines, the high-low clutch hub moves to the left. Now the internal splines engage the input shaft splines, locking the shaft, the input and output shaft together. The four-low position transmits the engine power from the input shaft to the output shaft through the planetary gear assembly. The high-low clutch sleeve is moved to the right. It engages the planetary spline piece and the planetary carrier itself. So as you can see here, now we're actually sending the torque through the planetary gears. Now the sun gear drives those pinions, rotating the carrier at a slower speed. This provides a gear reduction, causing the output shaft to rotate at a slower speed than the input shaft. So that's how we get our four-low reduction. When we shift from four-low to four-high while driving, this is provided by the use of a synchro mechanism, very similar to a standard transmission. As you can see here, we have the high-low clutch hub. This is our synchronizer key. It's going to make contact with the synchronizer ring. Now that ring pressure will slow down by contacting the input shaft cone, and it will slow down the two shafts to the shafts so they're both equal, and we can actually make the shift into the four-high. Let's talk a little bit about the part-time four-wheel drive systems. These vehicles are mostly operated in two-wheel drive mode. This directs the power to the rear wheels. When the driver manually selects four-wheel drive, equal torque is directed to all four wheels. Now this type of system consists of a front and rear diff with a center transfer case, but the transfer case has no center differential. These part-time four-wheel drive systems are designed for both the front and rear axles to rotate at the same speed when it's in the four-wheel drive mode. Now the power is split to the front and rear axles at 50% each. So four-wheel low is used only in very slippery traction conditions at very low speeds. Operating the system in four-wheel drive on drive pavement will actually cause the drivetrain to bind. There can have issues where especially during a turn, that binding can cause severe strain on the components in the four-wheel drive system. And it should only be used, again, like I said, in slippery terrain, snow, off-road, that kind of stuff. Most common part-time four-wheel drive systems used today are electronic shift operated. The electronic shift motor or actuator moves the shift fork to obtain the two-wheel and four-wheel drive, and also controls the high and low range as well. When shifting to four-wheel low, the transfer case must be selected into four-wheel drive first, and then the low range. This is similar to shifting like a manual shift transmission. Now, interlock pins lock the shift forks to the actual shift fork rail or shaft when you shift from two-wheel high to four-wheel high. When the shift fork is moved to the right by the actuator, as you see here in the top of the diagram, the interlock pin A locks the 2/4 shift fork to the actual shift fork shaft. Now the whole assembly will move to the right. At the same time, the shift fork moves the synchronizer sleeve to engage the four-wheel drive, as you see here down at the bottom of the diagram. Now when shifting from four-high to four-low, the shift fork shaft continues to move to the right by the actuator, and the groove in the shaft will align with the high-low interlock pin B, locking the shift fork to the shaft, just like it did before. Then when moving to the high-low shift fork, it will engage the high-low shift sleeve. You notice too in both of these diagrams, when we go to four-wheel high, let me back up one here. When we go to four-wheel high, like we see here, it activates the four-wheel position switch. When we go to four-wheel low, the shaft continues to move, and now we activate the four-wheel low position switch. These switch activations are actually sent to the ECU to control the four-wheel drive system. Now, full-time four-wheel drive system direct power to all four wheels all the time. So full-time four-wheel drives can be operated on dry pavement as well as slippery, unlike you can do with a part-time four-wheel drive system. This is capable because they use a center differential or a torsion equipped on these systems. Most common complaint and problem that I see with some of these Toyotas, and this one is pretty much a nightmare to deal with, the 4F4, the VF4 AM electronic shift full-time system, they have a lot of problems with the actuator leaking. Now, this system uses a dual shift motor with 2 shift shafts. Now, the problem with changing the actuator is when you try to remove it, the shafts are connected inside with clips and also bolts for the shift forks. So a lot of guys, what they're doing is they're forcing the motor off by twisting and turning it to remove it from the transfer case without taking the transfer case apart completely. What I want to show you here is this is the cover at the top of the transfer case. Even if you remove that, you can see where the clips are located on the shafts along with the bolts that hold the forks in place. So it's impossible to disconnect the shafts from the internal components to be able to get the shafts out with the motor. This is what the motor looks like. Obviously, this one already has one shaft in it. You can see how they come in leaking. There'll be some fluid in this area. What some of the guys are doing is they'll take the shaft out, and then, as you can see here, there's internal gears all for the timing of the 2 shafts. Now, these are the seals that normally leak. I've actually seen damage like this one from trying to assemble the transfer case actuator back onto the 2 shafts that are sticking out of the transfer case. There's a lot of guys on the internet. Some of these guys work at different dealerships that claim that they can twist and pull these off and put them back on without an issue. But I've seen some seals get torn doing it with that procedure. The noise and the sound that this thing makes when you try to do it that way is pretty horrendous. So it's up to you. Me personally, I would probably take the entire transfer case out and split it to get to the clips and the bolts for the forks. Now, full-time multi-mode four-wheel drive systems, they operate in four-wheel drive mode, but allows the driver to select two-wheel drive. Obviously, if they don't need the four-wheel drive, they can drive it in two-wheel mode. It provides more fuel economy, and it also reduces component wear because obviously we have less torque and load on the components in the transfer case. These also have a center diff in the system, so they can be driven on dry pavement as well as on slippery pavement. The center diff allows the power to transfer from the front to rear as necessary for better traction, and it prevents binding on dry pavement. Shift on the fly can come in many forms. As you can see here, you could have switches on the dash, you could actually have a knob to turn, or you could have an actual shifter that you'd have to move to shift on the fly. Most of these systems, they're not supposed to be shifted at speeds above 50 miles an hour, but some models will tell you that you can go as fast as 62 miles an hour. This is what a typical wire diagram looks like for a four-wheel drive system. You can see all the shift forks in here. This is the actual shift motor. This works pretty much like an electric drill that you'd buy from Sears. We run the voltage to one side. The motor turns one way. We reverse the polarity, put the power to the other side, and obviously the motor turns in the opposite direction. Now, on the electric shift control, when you select the 2-4 switch, when you push it on or move the shifter, whichever you do, the transfer shift actuator actually operates the 2-4 shift fork. Now, when that moves, the four-wheel drive position switch gets turned on. We were looking at that earlier where the shaft actually activates the switch. Now, the add actuator will operate, and the add position switch will come on, And once this is all complete, the 4 high indicator light will turn on the cluster. Now, ADD actually stands for Automatic Disconnecting Differential. Now, the ADD allows the four-wheel drive to be selected while the vehicle is moving. The front axle is locked after the shift into four-wheel drive. The ADD in two-wheel drive disengages the wheels from driving the front differential and drive shaft, obviously preventing any load or any load on any of the internal transfer case components. On earlier model four-wheel drive systems, the front wheel hubs were locked to the axles either manually or automatically when you shifted to four-wheel drive. Some of these vehicles you actually had to get out, lock the hubs, get back in and drive the vehicle. And then later on, some of them were designed to lock the hubs automatically. The ADD system eliminates any need for locking hubs. The front diff is an open type differential, so if one wheel slips, all the torque will go to the wheel with the least amount of traction, whether the ADD is activated or not. This is what the basic layout for an ADD system looks like. You can see we have a four-wheel drive control unit in the center. That controls the ADD actuator and the indicator lights on the dash. The ECU activates the actuator when the transfer case is shifted into four-wheel drive. So obviously once we've shifted the transfer case into four-wheel drive, there's our position switch, will send that signal to the ECU. Now the ECU waits until that position switch signal is sent to activate the actuator. Remember, like I said before, it has to be shifted to four-wheel drive before we can actually have the ADD actuator put the front wheel into lock position. Now the clutch sleeve will engage the differential side gear, closing the ADD position switch. Now when that signal notifies the ECU, as you can see here, this is the ADD signal coming back from the switch to the ECU. Once it notifies the ECU that the axle is engaged, and the four-wheel drive indicator light will illuminate on the dash. As you can see, the four-wheel drive control unit, it actually controls the lights to the dash as once it sees the signal coming in from the switch itself. Now the right axle is connected to the differential side gear and in an intermediate shaft through a movable clutch sleeve. When the side gear is disconnected from the axle, the left axle still turns and the left side gear is just like a slipping wheel with no traction. Remember, this is still an open rear on this front differential. Here's our pinion, here's our ring gear as we're turning, obviously, this side. Now the pinions will rotate the right side gear with no load and well lubricated because there's for no wear to happen on the components. So obviously with this turning all the time, it keeps everything lubricated. When four-wheel drive is selected, the ADD locks the front axle to the side gear. There's our intermediate shaft. There's our clutch sleeve. This is our actuator, and this is the lever that will actually push the sleeve over to lock the two shafts together. Once the side gear is coupled to the axle, the front differential sends torque to both front wheels. Now the clutch sleeve engages the axle, as I said before, through the intermediate shaft and side gear if moved by the actuator. Now this actuator can actually be operated by vacuum or it can be operated electronically. Now a spring-loaded weight mechanism is used to allow the splines and intermediate shaft and the clutch sleeve to mesh before the sleeve and shaft engage. This is a cutaway view of the ADD actuator. You can see our four-wheel drive position switch on the left and our low position switch on the right. And you can see we have a screw or a worm type gear, and it turns the outer gear or the drive gear. And we can see that there's some limit switches also in there. And there's our weight mechanism also located in the actuator. This is a typical wire diagram for a ADD system. Again, this looks very similar to the wire diagram that we were looking at on the four-wheel drive transfer case. We have an electrical motor. Obviously, we changed the polarity to either side of the motor to turn the actuator in both directions. And there's our switch signals that are sent back to the ECU itself. This is a vacuum-controlled actuator. If you look up here on the left, you can see it's pretty much the same thing as the electronic one. We still have a selector that will move the sleeve. And as you can see, the only difference with this one is that it's vacuum operated. Now this is the layout for a vacuum controlled or VSV controlled add system. You'll see here that we have an add relay, we have a vacuum tank, and then the relay will control which one of the VSVs to send the vacuum to either side of the add actuator. There's our add position switch. And as you can see, there's our four-wheel low switch. We have a neutral position switch on this one, and then the center lock position switch. And we also have the four-wheel drive position switches 1 and 2. Let's talk a little bit about rear locking diffs. Now, some of these four-wheel drive systems will have a rear locking diff that locks the differential, providing equal torque to both wheels. Again, this is an open rear, as you can see here. This is how the system is laid out. Once the four-wheel low position switch sends the information to the ECU, the ECU will now control the motor to the differential. Once it's in place, the differential lock switch will send information back for the indicator light. And the rear lock switch will also send information back to the ECU with that it's working, and it's also monitoring vehicle speed. This is what the rear diff looks like when it's unlocked. Obviously our torque comes through to the ring gear, goes through our spider gears right out to the slipping wheel. Once we do lock it, we actually move the sleeve over to the right by the actuator, and now this all becomes one connection, and now we have equal torque to both wheels. Okay, on-demand type four-wheel drive systems. These on-demand systems are what you'll find on a lot of the newer vehicles, especially on the smaller little vehicles like the RAV4s, the Matrix vehicles like that. They're real common on these vehicles today. These systems provide four-wheel drive only when it's necessary and the amount of the torque is distributed as it's needed. These systems can be initiated by the driver just by basically pushing a switch on the dash. On the front-wheel drive vehicles like the RAV4, the four-wheel drive system is not used until it's needed. Now, the on-demand type system used in the Matrix, it utilizes a viscous coupling to provide the four-wheel drive when needed. The 06 RAV4 system eliminates the use of the viscous coupling and replaces it with a much faster acting system, which also produces less drag. Now the 06 Matrix is equipped with a viscous coupling that's part of the transaxle. It's not available for 2007s. Now the RAV4 uses an electric coupling that is part of the rear differential housing and gear set, and we're going to go over that in the next few slides. Now all these all-wheel drive systems rely on the electronic control unit to control wheel spin by applying the brakes to the wheels, providing direct power to other wheels with traction. Here's what the layout looks like, and you can see there's quite a bit of different systems that the ECU is monitoring. As you can see, we have the four-wheel drive ECU here. It's also monitoring the steering angle. It's monitoring the yaw rate sensor, skid control. So there's a lot of things that it's monitoring. It's also monitoring all four wheel speeds. Okay, now the ECM is involved with this also. So all this works together. As you can see, this is just a basic front wheel drive, and the shaft that goes out of the differential to the right front wheel passes through this transfer, which is nothing more than a ring and pinion. Now this turns the rear output shaft or the rear drive shaft to the rear electronic or the electromagnetic coupling. This is a closer look at what that coupling is made of. Now the outer section of the main clutch is attached to the front housing. As you can see here, these are the main clutches attached to the housing here. Now the inner section of the main clutch is attached to the shaft itself. Now the control clutch, which is back here, this is actually attached to the control cam. Now the force of energy from transfer is transferred from the drive shaft to the front housing. So obviously the drive shaft comes in, and it's turning all this mechanism here, and that's the amount of torque that's going to be loading up the clutches. When the linear solenoid is actually activated, that's over here in the control section. Now when it's not activated, the clutch is basically not applied. So at this point the transfer, there's no transfer sent to the rear wheels. Now when the linear solenoid is actually energized, it becomes magnetized, and the electromagnetic force will pull the armature to attach the control side clutch. That's what we're looking at right here. Now if there's a difference in rotation speed between the front and rear wheels, the control clutch will begin to get applied. So if we're driving down the road, the front wheels start to slip, they'll actually start applying more amperage to the linear solenoid to get those clutches to clamp on. Now when this happens, you can see here that there's two cams, a control cam and a main cam with a ball in the middle. This is what the cam system looks like. So there'll be several balls going around this cam. So obviously the more torque that happens here will move the ball up the ramp and will also push the main cam forward, which applies the main clutch. Now once the main clutch is applied, that'll send all the torque to the rear wheels. Now the amount of rotating difference between the front and rear wheels will determine how much the system controls the current. The force of energy applied to the rear wheels will be gradually controlled. The amount of current will determine how much force will be applied to the main clutch. As you can see here, we're not applying too much force to the control cam, and in this section here we're showing you that we have an equal amount of torque going right through to the rear wheels versus this one here that has a lot of slip in it. Once we go into full four-wheel drive, when it's fully engaged, a light on the instrument cluster will indicate that the system is in full maximum four-wheel drive. At this point, the torque split will be 55% to the front drive and about 45% to the rear drive. It will disconnect at speeds above 25 miles an hour, or just by pressing on the brakes, it will be disengaged. Now this system, like I said before, it interfaces with a lot of other modules, but mainly the electronic power steering and the vehicle skid or stability control. Now a hybrid type on-demand system, they add a separate, excuse me, they add a separate electric generator drive system to the rear wheels. On those systems, you will not have a drive shaft. You'll just have the electric drive at the back wheels. This system operates in the same way as the RAV4. The only difference, obviously, is there's no drive shaft for it. This system will be activated by the traction control system. If you have a hybrid system, it also interfaces with the electronic power steering. Well, that's about all I have on the 4x4 stuff. I hope I didn't miss anything. I want to thank everyone for attending. I really appreciate your time. Again, we want to thank Seal Aftermarket Products for sponsoring the webinar. If you have any questions, please feel free to go ahead and click on that little hand icon by your name. That way there I know that you're actually typing something in, and I won't close out the seminar too early.